Good morning. I am Vishwasudan. Today we are going to present the topic about B-tree. The introductory part. It is divided into four subtopics. The firstly, we come across limitations of traditional binary tree search. The next is B-tree or balanced trees. The next, B-tree, also known as large key tree. Finally, time complex is always zero. Coming to time complexity, it is like you have seen in the table, the insertion, deletion, and searching is a big O of log n. Properties of B tree. All trees at the same level. B tree is defined by the term minimum degree t. The value of t depends upon disk block size. Every node except the root must contain at least one t minus 1 key. All nodes, including root, may contain at most 2 into t power t minus 1 keys. The number of children of a node is equal to the number of keys in it plus 1. Insertion of a node in a B tree happens only at leaf node. This is a pictorial representation of a sample B tree. The green ones are the child nodes, the blue are the leaf nodes, and the yellow is the root node. Transversal in B-tree. Transversal is also to in-order transversal of binary tree. We start from the leftmost child, rigorously print the leftmost child, then repeat the same process for the remaining children and keys. In the end, rigorously print the rightmost child.
Okay, now I will be presenting the search operation in B-tree. Basically, when we search element in B-tree, we will be starting from the root node. Then we will search whether the element is like if we see in this, if we want to search element 850. Now, if we see 850 is greater than 500, so it will check whether the number we are searching is greater than or less than the root node. So if it is greater than, it will go right side of the root node. If it is less than the root node, it will go left side. So basically, if you are searching 850, it will go right side and search whether it is 600 or 850. So we will be acquiring the element which we are searching. So this is how the search operation happens in B-tree. So as these points represent, it starts from the root and recurs traverse down. For every visited non-leaf node, if the node has the key, we simply return the node. Otherwise, we recurse down the appropriate child, the child which is just before the first great key of the node. Okay, so if we reach the leaf node and if we don't find the required element, it will return null. Next, this is a simple code for finding an element in a B tree. Before that's the same part, like this explanation is described in a code way. So this is a structure node, and then if we, in this node, in the while loop, we are searching whether the element is present. In while loop, we'll finding the location of the root node, and then we'll be recursing down the same way. For example, if you are finding the number 120, 120 is greater than 100, so it will go right side. Then it will go to second node, 130 to 180. So if we search with 130, it is less than 120 is less than 130. So it will recurse down left side, and we'll be finding 120 in the part. So this is step-by-step representation of finding or searching a node in an B tree. First, the search will be starting at the root node. Then, so if it will check whether 120 is greater than or less than 100, and then it will recurse down to the right side, and it will search 130 is less. It will find out that 130 is less than 120. So it will go to left side, and you will be finding the 120 element left on the left side of 130. So application of B-tree. It is used in large database to access data stored on the disk. Searching for data in dataset can be achieved in significantly less time using the B-tree. As we saw that the time complexity of B-tree is O log n. So it is basically the best time complexity we'll be ever facing in a searching operation. With the indexing feature, multi-level indexing can be achieved. Most of the servers also use B-tree approach. B-tree are used in CAD system to organize and search geometric data. And advantages of B-tree. B-tree have guaranteed time complexity of O log n for basic operation like insertion, deletion, and searching, which makes them suitable for large datasets and real-time applications. B-tree are self-balancing, high concurrency and high through output, efficient storage utilization. And mainly the we come to disadvantage of B-tree. B-tree are based on disk-based data structure and can have high disk usage. Not the best for all cases. Slow in comparison to other data structures. And thank you.